So I want to try to explain you this project which hit us, so to say, back in 2010. It's a project in Milano, in Italy. The architect wanted to have this, it's Aqua World called, it's a big swimming and fun park, and they wanted to have one part of the roof green, so the backside of the building should have become green. The problem for us was it's up to 60 degrees of slope, and normally we say we'll do green roofs up to 45 degrees and then we stop, but yeah, we... Okay? Yeah. So normally we stop at 45 degrees, but in this case we thought, okay, let's give it a try. So this was highly complex. Some facts about the project. It had a roof surface of about 2,000 square meters. The pitched areas were not only pitched, they were also banded, and up to 60 degrees, as I said. Then the substrate layer was maximum 8 centimeters because of load restrictions of the whole building. Then we had extreme flow lengths of up to 20 meters, so the water had to travel 20 meters from the top to the down, and all the weight of the substrates also had to stay on the 20 meters of length. Yeah, we had the next problem was that the underground was three-dimensionally curved. That means we couldn't fix the shear forces at the bottom. We had to fix them at the top somehow. Of course, we had to transfer the shear forces through the waterproofing. And normally we from OptiGreen, we have the idea that we should not penetrate the membranes, because every penetration to the membrane is a potential danger, potential risk for the building. So we normally try not to do that, but in this case there was no other way to do it. So the roofing installer, he really had to close those penetrations properly. Then they wanted to have a low maintenance vegetation, and yeah, the problem was until then there was no project of a similar size being done before. We did one before, which I will show you. So our basic approach was to use this Type S system, the cable and sill system, which Heiko just presented to you. So by using this system, we were able to put the shear forces at the top of the building. We could follow the horizontal and the vertical bends of the roof surface quite easily, but we had to apply a 10 millimeter stainless steel cable. Normally we can do it with less material, but in this case we had so big shear forces, so we really had to use massive material, which unfortunately made it quite expensive. And the problem during the building and the construction phase was that the position of the sills depended on the angle of the roof, and the distances varied from roof section to roof section. I will show you a drawing of that. So it was really complicated in the planning and afterwards in the installation. And the installation team, they really got almost mad in finding the right place to put the sills on the roof. And this comes back to the point Heiko said, that in such systems, installation cost and time is mainly or mostly more than the cost of the product because of that. So this was a small project we did before, and this was based on the experiences we made with this project. We thought, okay, we can handle the big one in Milano as well. So this one was built in 2006 in Austria. This is a clubhouse of a golf course, and it's quite nicely and small. It's quite a simple design. It looks like, I don't know, UFO or something like that. And the architect, he wanted to have heavy green from here to there. So we said, no, we have to stop here. We stop at 60 degrees, and those areas, they were made green from the bottom. So they were using some plants who grow up from the bottom, and I think that's the idea. So this was the plan of the building. These are the fixing points where we hang in the ropes afterwards. So you can see here we have quite many fixing points. They penetrate the membrane. It's a bituminous membrane, and these penetrations were sealed again after penetrations, and those elements, this is stainless steel elements, and we placed them according to the dimensions of the roof, and we told the architect where to place them. Here we already hang in the cables, so the system is already applied. In this case, it was not so complicated because the shape of the roof was even. It was the same shape everywhere, so you just hang in the cables and the sills, and that's it. Here we install the substrate. We start from the top, and then we work our way down, and until here, and then here we start with the 60 degrees where we didn't want to apply any greening because it wouldn't stay there. So that means the plants, they have to grow from here upwards. This is how it looks in wintertime. So we also had to cope with the snow. So this is more than 50 centimeters. I would say it's a meter. It's in Austria, close to in the back. This is the highest German mountain called Zugspitze. So it's in the winter. It's a nice ski resort over there. So we really had to cope not only for the weight of the substrate, but we also had to calculate the weight of the snow. Yeah, coming back to the one in Milano, slightly bigger. That's a view from the inside. So down here we have the swimming area, and this is the view to the city, and on the back side is the side which should have become green. This is just the plan of the building. If you compare it to the golf course building, it's much more complex, different shapes, different angles, so quite complex. The lines you can see here, these are all the steel cables we planned for this building. So you can easily see different lengths, different dimensions, different distances. Here, different angles. So it was really quite complicated. Just to give you an example, for every area which we had more than 30 about and more than 90 cables, we calculated every area individually, and we made a plan and a drawing for every single cable. In addition to that, we had to calculate the weight, the individual weight going up here, in order to make a proper dimension of the metal beam in there, which copes for all the shear forces and all the weight going down. And here you can see the dimension. So it's a 3-meter section here, and this is about 20 meters or something. So it's quite a long section. This is during the building phase. You probably can imagine it's not that easy to get all that stuff up there and find the right place where to put it in. This is application of the substrates. If you build sloped roofs, please always start at the top of applying the substrate, because the whole system will just move a little downwards. So you really have to start at the top in order to have a stable and a system under tension at the end of the day. This is the irrigation. Of course, in Italy, you also need irrigation for extensive green roofs, which we normally don't have in Germany. But here it's irrigation in there. It's a sprinkler concept being used here. It's a normal type which is on the market, so it's nothing special. It's just a normal sprinkler system. This is how the roof looked this year in May. So it looks quite nicely. It's okay. I didn't show you this flat area. I mean, this is just quite simple. I was talking about this area which goes in this direction. This one was also not that difficult. It's more or less not that steep. So we were talking about this area. Another picture. Yeah. Okay. After talking or explaining a little bit the pitched roof, and the point we wanted to make is pitched roofs are possible, and pitched roofs are basically the nicer green roofs because you are really able to see them compared to the ones on flat roofs, which you very often don't see. But the problem is they are really much more complicated. You have to spend much more time thinking about the technical solutions, and there's it's really hard to define a standard for that. So every project is different, and every project is not just out of the box. Like an extensive green roof on a flat roof is something you really easily can do. That's no problem. But the sloped ones, every project is different, and every project requires special thoughts and special things to look about. Okay, then coming to the end, I just want to talk a little bit about the components in a green roof. We showed you at the beginning the systems we are using, and now I would like to talk a little more about the most important components of a green roof. I don't want to elaborate on all components, but just the most important components, which are basically two. It's the substrate and it's the drainage layer. In addition to that, we have a filter layer, the protection layer. We have control shafts around the outlets of the roof and stuff like that, but this is not so important. So the two major factors of a green roof is the substrate and the drainage. The reason for this kind of, we say it's a three-layer build-up. So one layer is the drainage layer, then we have the filter layer as the second one, the third one is the substrate layer, and this is typically called a three-layer build-up. In comparison to that, there used to be some one-layer build-ups where you just had substrate, no drainage, and this always or very often caused problems because then you depend on the substrate only, and if this fails, then the whole roof fails. So therefore, we moved away from this single-layer system to the three-layer system. So the three layers basically have a couple of advantages. First of all, by using a drainage layer, it's much easier to control and calculate the drainage and the water storage. So this is typically a plastic element with defined values, defined water discharge values, and water storage capacities, and so on. So it's easy to calculate that and to control it. Then it has proved that the vegetation has develops better on three-layer systems because the substrate on a three-layer system is much more made for the vegetation. We have better control of water storage, which is quite clear. The elements have a defined water storage capacity, and of course this system has a much lower weight than a system using gravel build-ups. To give you an example, a drainage board water saturated is about maybe 8 kilograms, and if you take a 5 centimeter gravel layer, this gives you, this gives you about 50 kilograms of weight. So there's quite a big difference between the two. Talking about the substrates a little more. For us in Germany or surrounding countries, it's quite easy. We have this so-called FLL guideline. This is more or less the Bible for the green roofing industry. Many countries just translated it into their countries, and this gives key criteria for substrates. And we put up some of the key criteria up here. The first one is the drainage function. So in the guideline, it's defined that a good substrate has to have this drainage function, which goes from 0.6 to 70 millimeters per minute. So the water has to travel minimum 0.6 to 70 millimeters from up to the top per minute. So this allows you that the substrate always is able to take in the water and drain it downwards to the drainage board. Then the next point we have is the maximum water storage. So in the guideline, it's defined that a good substrate should store 35 to 36% of volume of water. That means in 1 cubic meter of substrate, you are able to store 350 to 650 liters of water, which is a tremendous amount, if you imagine that. But this is very important, especially for dry areas like many places in Turkey. So it's really an important factor. The next one is the organic content. When they started with green roofs in Germany, maybe 30 or 40 years ago, the substrate had a lot of organic content, because organic content is normally meant to be good for the plants, and it's lightweight and it's relatively cheap. So they used compost and turf. But it showed that after a couple of years, the organic content just disappeared. It was just gone, and at the end of the day, the whole substrate lost its function, and therefore we have this definition now in these guidelines not to have more than 36 grams per liter of organic content in order to prevent that. Then it's a weight range defined. It goes from 0.9 to 1.45 tons per cubic meter, water saturated. Just to give you an example, a normal soil out of the garden is something like 1.8 to 2 tons water saturated per cubic meter. So this substrate is less than half, or it's about half of the weight. So that means that the total weight to the building is much less than with normal soil. Then there's a defined pH value to the soil. There's a salt content. Too much salt is also a problem for the vegetation. And by using all those key criteria, we come to a high plant variety. There are a couple of more. There are some more in the guideline, like things like grain distribution and stuff like that. So, and there's an English translation available as well. So if somebody wants to go more into detail, just feel free to look in there or ask whatever you might ask. Just to show you this substrate, we take the name of substrate. We are not talking about soil because it's artificially mixed, blended. It's made of natural components like lava, pumice, broken bricks, compost. So it's all natural ingredients, but it's man-made. This is just an example. It shows you how it's kind of stony. There are small stones in there, and this gives this special grain distribution which is required. So this is a type E substrate for extensive green roofs. Has a high nutrition content, good drainage, high water storage, and a weight of about 900 to 1,400 kilograms, water saturated. If you look on the next substrate, this is a type E for intensive. This is more fine because it has a lower mineral content, only about 65%, where the other one, the type E, had about 85%. Has a very high nutrition content, very high water storage, up more than 40%. Or let's say if you take it in liters per centimeter, if you have a 30 centimeter high substrate, on an intensive green roof, we can store 120 liters of water per square meter in this substrate. And the weight is slightly higher. It's 1,100 to 1,400 kilograms, always water saturated. Talking about the drainage, I just want to show you the different drainage boards which we offer. This is the typical drainage board, the FKD 25 for a normal extensive green roof. It's 25 mil high, has a compressive strength of about 251 kilonewton per square meter, and has a pretty fast water discharge of the surplus water. And this is typically measured. It's typically measured at different slopes. So we start with 1% pitch. There we have 0.99 liters, and the steeper the slope, the more water discharge we have. The board stores about 5 liters per square meter, and for Turkey we have to apply minimum 7 centimeters of substrates on top of this layer. And for installation we always advise to overlap one row and do not make cross joints when it's installed. And if it's a windy day, it's always advisable to fill it with water during installation, because then it gets more heavy and then it stays on the roof. Otherwise it tends to fly. They weigh about 1.4 kilogram per square meter, so if it's really windy day, it's somehow difficult to keep them on the roof. Then the next one is the FKD 40, as well used for this extensive green roofs. If you remember from the speech of Heiko, this is the nature roof, the so-called, which is a little higher extensive green roof. Has a compressive strength of 170 kilonewton and has an even better discharge of water. So talking about, let's say, if you have a big roof with a flow length of maybe 40 or 50 meters, which can easily happen, we very often combine an FKD25 with an FKD40 because the water discharge of this FKD40 is much higher than the FKD25. So what we do is the first 20 meters we are using the FKD25. Then this FKD25 comes to its limits, and after that we apply the FKD40, which can discharge more water. If you compare the figures, so we have 1.6 liters here at 1% pitch, and at the FKD25 it's only 0.99. So it's about 60% more. And so the combination of the two drainage boards helps us on bigger roofs. This is the FKD60. This is used on intensive green roofs. It's 60 millimeters high. The compressive strength is very high when it's filled with drainage material. It's about 700 kilonewton and has a sufficient discharge of surplus water. It's less than an extensive one, but you can imagine if it rains and you have about 30 centimeters of substrate, which will store the 120 liters, there's not a lot of water which comes down to the drainage board. It stores 23 liters within the holes. Within here, the areas, it's about 23 liters. That's a very special product we are using in middle of Europe, where we have this heavy rainfall events. They are specially designed for handle stormwater events, where we have a severe rainfall in a very short time span, where we have a so-called rainfall which should appear only once every 100 years, and for this we have designed this product. So that means that during this rain event, which is typically only 15 minutes, we can store most of the water in the drainage board and then discharge it later to the sewer system. And especially for areas where you have high rain events, this could be a good alternative to help the public sewer system not to overflow during heavy rainfalls. Yeah, this is a drainage board which doesn't store any water. It's used for those traffic roofs. So if you want to drive with cars or pedestrians on the roof, we have two different types with two different compressive strengths, depending on the type of traffic roof you plan to build. The FKD10, it's this one here. This is has a compressive strength of 400 kilonewton per square meter for pedestrians only, and the FKD12, which is basically the same shape but much more strong, has a compressive strength of 1,600 kilonewton, which gives you 160 tons roughly per square meter. So this can be used for cars and trucks. Some words about irrigation. Depending on the area in Turkey, we should think about necessary irrigation. There are different concepts which are possible. Either you install an above-ground irrigation system like with sprinklers and drip systems. The disadvantage of these systems is that they lose kind of a lot of water to the air, so that the water usage is quite high compared to the result. So it's advisable to use an underground irrigation system with drip hoses and stuff like that, because then you need much less water. The third alternative is something which only can be used on 0-degree roofs, and this is a permanent water level in the drainage layer. So there's an automatic system which always keeps about 3 to 5 centimeters of water in the drainage level, and the roots of the plants just take the water out of there. But this really only works on really flat roofs with 0 degrees. Yeah. Coming to the end. Green roofs, plug and play. On simple, extensive, flat roof, I would say yes, plug and play. If you come to sloped roofs, please don't plug and play. Just think about how we could do it. BTM and we are really happy to help you on that, but it really needs some consultation, some ideas how to solve this problem. Yeah, now back to work. Just a small film for the end. How we do green roofs in Germany. That's about the speed we are doing that. No, just kidding. I don't know, are there any questions? If you want to ask a question in Turkish, please feel free. I get a translation and then I try to handle that. Otherwise we could, I don't know. No question? Oh, there in the back.
Öncelikle teşekkür ediyorum. Ümit Sönmez. Sorum şu, tek kademeli sistemden bugün 3 kademeli sisteme geçmenizin bir sebebi de acaba suyun filtrelenmesi meselesi olabilir mi ve moleküler olarak suyun mikronize toprak parçalarıyla şey edilmesi, karışması dolayısıyla meydana gelecek tortulanmayı önlemek için mi filtrasyon ve 3 kademeli sistemi seçtiniz?
What is the main difference between the single system and the three-layer systems? Is it for against the problems that occur in the substrate and water?
Yeah. Okay. Yeah. The question was, where's the difference between the single-layer system and the three-layer system? The single-layer system, which is there, the drainage layer is made out of the substrate. That means the substrate has to have two functions: drainage and place for the roots of the plants. And if the substrate is poorly formalized and poorly made, then the whole system fails because the drainage function is not there. This is one point, and the other one is that a substrate which should store, which should work as a drainage layer, can store much less water. And that's the reason why a system, a monolayer system, is not possible for areas like most areas in Turkey where we have long periods with very low rainfall.
Mikrofon. Bir de ilave olarak şunu soracağım. Bu 3 katmanlı sistemde suyun içine mikronize toprak granülleri karışarak suyun efsafı bozuluyor mu? Ve bu sonradan filtre edilmek zorunluluğu çıkıyor mu? Özellikle eğimli çatılarda.
No, in pitched roof it's not filtered because there we are using this, if you remember, this type E substrate for the extensive green roof. And this substrate has no small components which could block it. So this, and of course the slope of a pitched roof allows the flow of the small particles to the drain. Yeah?
Thank you.
Okay. Other question?
Merhaba.
Hello.
Bu kullandığımız izolasyon malzemesinin ömrü ne kadar? Yani kaç yıl süreyle biz bir yeşil çatı yaptığımız zaman o izolasyon malzemesi su geçirimsizliğini koruyabiliyor. Yani bir yapılan bir sertifikadan, yani alınan bir sertifikadan bahsedildi ama orada sadece şey söyleniyor. 2 yıl boyunca ateş dikeninin köklerine dayanıklı olduğuna. Bir ömrü var mı sistemin? Yoksa şey mi? Bunu öğrenmek istiyorum.
Yeah. Okay, what Mr. Bonfield showed was the testing method for the root protectiveness of a membrane, and this is typically done just for the 2 years with special plants which are very aggressive to the roots. And they just do it over 2 years because it's done in a greenhouse, so the plant grows every year. And the assumption, it's not only the assumption, that this test was done in the year 1982. And since then, the test was not really totally modified. So, and they really found out that the test pretty much shows the reality. So it's not a problem that it's only 2 years, but let's say you cannot, as the industry, you cannot test it for 10 years, and then you are not able to sell the product for 10 years. Therefore, they reduce it to 2 years, but they use much more aggressive plants for the roots. So therefore, it's proven that we have many green roofs which we installed 40 years ago, which are still there. And so it's not a problem. It's the other way around. A green roof lasts double the time than a non-green roof because of the membrane is just protected by all these effects, UV radiation, hailstorms, all that stuff. So that's definitely proven that a green roof lasts twice as long as a non-green roof. Yeah. Yeah. Mm. Yeah. Okay. Yeah. My colleague just mentioned that in the last years, of course, once in a while you have to remove a green roof because they want to remodel the building, and we never found a system where there was leakage to the membrane. So the membrane was always intact, it was always working. It's normally, if there's a problem with a green roof, then it starts after 2 or 3 years, and then it's poor installation and mistakes during installation of the membrane. And if the membrane once is under a green roof and there's no installation mistake, then there's no problem at all. If the membrane has passed this test. I mean, this is really crucial. There are many membranes on the market which did not pass this test, and I wouldn't build a green roof on membranes like that. And that's what we are always saying. We require always membrane who have passed this test, and then it's fine. Of course, it should be a BTM membrane, but it doesn't have to be necessarily. Sorry, no, just kidding. No, this is really important to have a membrane which passed this kind of a test, and then you are on the safe side. Okay.
BTM firması proje hizmeti de verecek mi acaba? Yani herhangi bir çatıda nasıl bir detayı kullanılacağı, birleşiminin nasıl yapılacağı, drenajının nasıl yapılacağı, tahliyesinin nasıl yapılacağı, kaç santimlik toprak kullanılacağı, ne kalitede toprakların kullanılacağı, en fazla ne kadar yükseklikte bir çözüm yapılabileceği, bu tarzda proje bazında da yardımcı olabilecek mi?
Tabii ki proje bazında yardımcı oluyoruz. Proje bazında su yalıtım kalemlerinin seçiminde, su yalıtım detaylarının çözümünde, daha sonra yeşil çatının altyapısının oluşumunda, yani orada hangi türdeki o eğime bağlı olarak kullanacağınız bitki türlerine bağlı olarak oradaki hangi türdeki keçeleri kullanmanız gerektiği, hangi türdeki drenaj malzemelerini kullanmanız gerektiği ve hangi türdeki gerekiyorsa kaymayı önleyici sistemlerin, eğer eğik bir çatıdan konuşuyorsak o projede hangi türdeki kaymayı önleyici sistemlerin, S-tip mi, T-tip mi yoksa kablolu sistem mi, hangi sistemleri kullanacağınız konusunda sizlere bu proje hizmetlerini veriyoruz. Eğer bu eğik bir çatıysa bunda gerekli bir takım statik hesaplar yapılması gerekiyorsa bu statik hesapları Almanya ile birlikte çözümlüyoruz. Toprak ve de bitki konusunda burada muhakkak surette bir peyzaj mimarıyla birlikte çalışmanız gerekiyor. Dikkat ettiyseniz gerek bizim sunumlarımızda gerekse OptiGreen firmasının sunumlarında sonuçta oraya ektiğiniz bitkilerin bir bakım süreci var. Çatı ömrü boyunca yapılacak olan bir bakım süreci var. İşte o bakım sürecini size en iyi yapabilecek olanlar peyzaj firmalarıdır, peyzaj mimarları firmalarıdır. O yüzden toprak ve de bitki seçimlerini onların birazcık da doğrultusuna bırakıyoruz ama tabii ki bitkilerde şöyle bir olay var. Bizim Türkiye'de herkes yeşil çatı dendiğinde çimeni anlıyor. Çimen bakımı en zor olan ve de en çok suyu isteyen bir malzeme. Bu durumda biz kendilerine bu tür çatılarda, özellikle ilk çatılarda çimenin en son düşünülmesi gereken bir ürün olduğunu, onun yerine Türkiye'de çok daha fazla, daha az bakım gerektiren, daha az su gerektiren çok fazla türde bitki olduğunu, özellikle sedum bitkilerinin olduğunu ki Türkiye'de daha sonraki konuşmacılarımız da bunu anlatacaklar. Yanılmıyorsam 30'a yakın sedum türü bitki bulunuyor. Bu bitkilerle bu çatıları çok güzel bir şekilde yeşillendirebileceklerini ifade ediyoruz, söylüyoruz ve bu konuları seçmelerinde, bitkileri seçmelerinde de yardımcı oluyoruz. BTM'nin genel sunduğu teknik hizmet bu. Daha sonra bunların uygulaması konusunda hizmet veriyoruz. Yani uygulaması derken su yalıtımının uygulanması ve de çatının, yeşil çatının alt sistemi, toprak ve bitki hariç alt sisteminin oluşturulmasında gerekli olan uygulayıcı firmaları sizlere yönlendirerek bunların uygulamasını sağlıyoruz.
Okay, some more questions? Thank you.
Şimdi 15 dakika bir kafe break molası veriyoruz. Bu arada ilk gelen misafirlerimiz yanlış hatırlamıyorsam danışmadan girişte kayıt yaptırdıkları yerden numunelerimizi ve katalogları özellikle Optigri'nin sunumunda yer alan ürünlerin yer aldığı, katalogların yer aldığı USB bellekleri teslim almamışlardır. Bir katım misafirlerimize bu teslim edildi ama ilk gelen misafirlerimiz danışmadan bunları temin edebilirler. 15 dakika sonra tekrar bu yerde olacağız. Teşekkürler.